card and yeah, this. Okay. So question number 10, give an example of a relation. First one is which is symmetric but neither reflexive, symmetric only. Okay, that's the one we want. So this basically, when they say example, there's a possibility that you get 1 mark question in this. It is given a couple of times, it's asked. So let's see, we can actually say A is equal to like 1, 2, 3, 4, some 4 numbers you can take. R is a relation, R is relation in A, and R equals to 1, 2, 2, 1, because we want this to be symmetric. Okay? 3, 4, and 4, 3. 1 second, I'll just respond on phone call is coming. I'll be back.
Yes, sir.
Sorry, Sam, I'm back.
Sir.
So we have done 1, 2, 2, 1, 3, 4, 4, 3, and we close this. Now we'll check whether this satisfies the condition or not. Definitely 1, 1, 2, 2, 3, 3, 4, 4. This is not there, therefore not reflexive. Okay, so it's clear. Then the next one is it's a symmetric or not. 1, 2 is there, 2, 1 is there, 3, 4 is there, 4, 3 is there. So it's a symmetric. The next
Okay,
one
sir.
is whether it is a transitive or not. So 1, 2 is there, 2, 1 is there, but 1, 1 is not there. 1, 2 belongs to R, 2, 1 belongs to R, but 1, 1 does not belong to R. Therefore, not transitive. So you don't have to write. If it is a 1 mark question, you just write this and this. All other things you don't have to write. I'm explaining because you need to understand that. Okay. So question number 2. 10 to 10th main second. Transitive but neither reflexive nor symmetric. So only T only. So in order to have T only, so consider this very similar one on the same. You can have one more 5 also. You can say B is equal to 1, 2, 3, 4, 5, and the relation is you need to have 1, 2, 2, 3, and therefore you must have 1, 3 definitely. So you have 1, 3 and take 1, 4, okay, and 4, 5, 1, 5. I think we can set up in such a way that in this 1, 1 is not there, 2, 2 is not there, therefore it's not reflexive. 1, 2 is there, but 2, 1 is not there. Therefore, it is not symmetric. Okay, so it's only transitive. Then coming back to the third one, reflexive and symmetric, but not transitive. So third question, we'll be doing it fast today. Okay, most probably we'll complete this exercise. Okay, how did you write the
Yes,
maths today? Only maths test, right?
yes, sir. It is easy.
You did well.
Yes, sir.
Did well. Okay. So if you see the first main third one, first main third, first main third question. So there we already answered that. So we have said y is divisible by x, and we answered that as a reflexive and transitive. So you don't have to remember or write anything new. Okay, you can just give that example. So that is taken care. Fourth one, reflexive and transitive, but not symmetric. Fourth one, not symmetric. So that means you have the previous one, which is reflexive, right? So we just did this one. This is right now transitive only. Let's suppose we include 1 1 also. 1 1 2 2 3 3 4 4 5 5 in that. Okay. Then automatically that means for the second one in 2 above, add 1 1 2 2 3 3 4 4 and 5 5. So then that becomes, it was already transitive and it becomes reflexive also, and not symmetric. Why not symmetric? Because 2 1 doesn't belong to that relation. Therefore, it is not symmetric. The last one, symmetric and transitive, but not reflexive. So these are all easy, symmetric and transitive. So I'll take a next page. So fifth one. So it has to be symmetric and transitive, not reflexive. So let's take C equal to 1, 2, 3, 4. So we consider the relation R to be 1, 2, and so it should not be reflexive. That's all. Okay. Then if I take 1, 3 for example, 1, 3 is there, and then uh, you need to have 3, 1. Okay. So let's not do that. Symmetric and transitive, but not reflexive. For symmetric, let us take 1, 3, and say 3, 4. Then we have 1, 4. So 1, 3 is there, 3, 4 is there, and then 1, 4 is there. Okay. So this is transitive. If I have 4, 3, this is a problem. If you take this kind of a things, right? You'll have 4, 3, and then it's a symmetric. Then you have 4, 1, and then 3, 1. Okay. This becomes not transitive. So this example, we have to be careful. He wanted this to be transitive, and therefore we cannot have this. So we need to figure out how do we pick up the things in such a way that it is. So we need to bring in a relation so that, you know, so what kind of a relation we can bring in? It is something like x minus y is this, or you may have any other relation also. So not reflexive, that means um, yeah, we can actually take off this and say C is a family of, okay, uh,
Yes, sir.
brothers and sisters. Okay, brothers and sisters. So now let's say we are picking up any two of them. Okay, so you can have the brothers and sisters, maybe say A, B, C, D, E, or whatever. In the family of this, we are taking the relation as sibling x, y such that x and y are siblings. Okay, so which means you can have A comma B. That means A is sibling to B, then B is sibling to A also. Okay,
Yes, sir.
but then you can have, I mean, I don't want to write it here. If you write it, then automatically it will say, sir, A and A also should be there. Actually, so you should not write with A and A. You just write this part, this is sufficient. That means a person cannot be, sibling to himself, cannot be sibling to self. Therefore, it is not a reflexive relation. So don't write this, don't write this, don't elaborate it. This is right, this you write, and this you write, sufficient. Okay, that's a fifth question. Now we are
Yes,
going to the 11th one. 11th question. Show that the relation R in the set A of points in a plane given by R is equal to P comma Q. The distance of P from the origin is same as the distance of point Q from the origin. That means we have a plane, plane can be like anything. So we have 2 points, this is P and this is Q. So distance of P, that means it's OP, is equal to the same thing, OQ. Okay. So we have to show that it is an equivalence relation. Okay. So we have to take set of points. So in this plane, you've got so many other points. So let plane has points P, Q, R, S, T. Some points you are taking it. This is a set of these points. Set of points plane. So, but then now the relation R you are picking up in such a way. The relation R, you have PQ and you have PR and you have QR and you have QS and you have ST and you have TS and you have QP, okay, and you have RP. I'm just writing so that they are symmetric actually. And then you have RQ
yes, sir.
and you have SQ. So now when you have these things, so distance OP equal to OP. So that's why PP also must be there inside this, and it is there. PP, QQ, RR, SS, and TT, all are there. Therefore, OP equal to OP. Therefore, it is a reflexive relation. The next one, PQ belongs to R. Also, QP belongs to R. Therefore, it's symmetric. That means all points are, I think you can give all examples also. The third one was PQ belongs to R, QR belongs to R, and that implies point P and R also belongs to relation R. Therefore, it's an equivalence relation. Okay, so we have proved that's equivalence. Further, show that the set of all points related to point P, which is not equal to 0, 0, is the circle passing through P with origin as center. So now what we have to show is that since OP equal to OQ equal to OR equal to OS, that's equal to OT, so that is nothing but PQRST are loci which are locus of the loci, right? These are the points which are equidistant from O. Therefore, that locus is a circle with OS origin. That's it. Okay. 12th question. You may have to try this. Show that the relation R defined in the set of all triangles T1, T2 like that is an equivalence relation. That we have to do. After that, consider three right angle triangles T1 with these sides and which triangle among T1, T2, T3 are related. Okay, let's see the first question. Okay, so triangles T1, T2, T3, all triangles. So T1, T2, T3, etc. are similar triangles. So I think there was a disconnect, right? Hello? Hello? Hello, Sam?